Hello everyone, welcome back to Cambridge Group. The last video was about accuracy. The second topic of accuracy that we covered was upper bound and lower bounds. The next topic we are going to cover is surds. And this is a very important topic because as I told you in the last video that we have paper 1, I mean the component number 22 and 12. These are without calculator, and this surds or dealing with surds is very important. So what is surd? Any number which is written in square root or cube root form, right? Suppose square root of x. So I will call this as a surd. If I say root x into y, this is also a surd. If I use cube root of x and y, this is also a surd. If I use cube root of x and square root of y, this is also a surd. And I think there is no need to deal with the square roots and all. I think you very well know how to find out the square root of something because this is part of the checkpoint or level 7, grade 7 and 8th topics. Okay, so any number which involves the square root, cube roots, the representation is called the surd form, right? And if suppose I have cube root of 27, although this is a surd form, but actually it is not irrational number. This will give me the integer or the whole number value, which is 3. So 3 is not a surd form, but cube root of 27 may be regarded as a surd form because it is written in these surd form or square root or cube roots form. Okay. Now one more thing that you need to revise is what is called as the exponent form of surd. So if there is a number which is written as square root of x, I think you very well know this, that if there is no number written here, we consider this as a square root. Okay, so this is written in exponent form as x raised to power 1 by 2. Okay, if it is cube root of x, so we mention this as x raised to power 1 by 3. Okay, if this is fourth root of x cube, so we will write x cube and then 1 by 4 of whatever is inside the square root. Okay, let us take one more example. Cube root of x square y raised to power 5 will be written as, you write whatever is inside the square root as x square y raised to power 5 and then just take 1 by 3 of whatever is inside the square root, cube root. Okay, so all these are surds form, and you should, if you are okay with dealing with the indices and exponents, laws of exponent, then dealing with surds will become easier to understand. Okay, fine. Now next comes the properties of surds. There are just two properties that you are going to learn about. So properties, the only two properties that you will be using. The one property is, let's suppose there is a number written as square root of a and this is multiplied by another number as square root of b, and this is valid for cube root also, or any one of the root is not any one of the root. These two roots must be same, whether it is a square root or cube root or whatever it is. So what you can do is you can multiply these two numbers first and then take the square root. In words, how we can convey this, that taking the square roots of two numbers separately and then multiplying is equivalent to multiplying two numbers first and then taking the square roots. Okay, so reverse process holds. You first multiply, then take the square root, or you take first the square roots of both the numbers and then multiply. Those two values will be equal. Second is, of course, for division, that if two roots are in division, square root of a divided by square root of b, this can be written as a over b and then take the square root. Okay, and of course the condition here is that b should not be equal to 0, because when b is 0 the denominator becomes 0 and this is not allowed. Okay, fine. The third property I won't say, but this is just a word of caution that root a plus root b is not equal to a plus b root. This is a word of caution. Okay, whatever is valid for multiplication and division is not valid for either subtraction or addition. Meaning you have two numbers, you take the square root of those two numbers separately and then add or subtract. This won't give you the same answer by first adding or subtracting and then taking the square root. Okay, I think this is quite clear. You can take one example also, you can verify. Okay, let us say a is 9, b is 4. So root 9 plus root 4, this will give me 3 plus 2, which is 5. And then if I add these two numbers, 9 plus 4, and then take the square root, this is root 13. And of course, root 13 is not equal to root 5. Same goes with subtraction. Okay, this you can verify. And we will do this by taking some examples. We won't verify this. It is quite understandable. Okay. So the question can be simplify the following. So as I told you, these two roots are calculated separately. This can be written as that you first multiply 5 with 20 and then take the square root. So this will give me a square root of 100, which is 10. Okay, so it appears that the original number, both the numbers are irrational, and this satisfies our property, very important property, that if two irrational numbers are in multiplication, root 5 is irrational, root 20 is also irrational. Two irrational numbers in multiplication may give you rational number. This is the perfect example of that property. Okay. Again, root 72 upon root 6, I can write this as 72 over 6 and then taking the square root, which is equal to 72 goes by 12 times 6, so this is 12 and then square root of 12. You can leave the answer here. And sometimes division of two irrational number may give you, of course, an irrational number. Always will give you the rational number, it is not the case. Okay, had it been any other number other than 6, you might get a rational number, just like in multiplication. Okay, this is one type of question that of 1 mark you may get in paper 1. Second type is writing root 288 in the form of a root b, where a and b are integers, right? And this is also very important, which are used in some other topics also. Okay, dealing with again non-calculator based questions. So here what we do here in root 288 is that we write this 288 as its prime factors, and not just prime factors, such that you get a number which is a perfect square. Because I know that, for example, I have root 9. Root 9 can be written as just 3. Root 4 is 2. Okay, root 16 is 4 square root, which is 4. Okay, and so on. So you must be noticing here that the number which is inside the square root, it's raised to power some even number, right? And that number with half of that power will come out. If you take the square root of, for example, I'm just showing you the example, that if you take the square root of 81, okay, you will write this as 3 raised to power 4 and then square root. So you get answer as 9. Why 9? Because this 3 raised to power, just like I said, that you need to divide this even number by 2. You get 3 square. So number which will come out is 3 square, which is 9. Right? And if you repeat the process, if any number has to go inside the square root, it will become squared, and any number which is taken out of the square root, that becomes half. The power of that number becomes half. Okay, so in this case, this is 2 into root 44, and I know this, that I can write this as root 2 into root of 144. Okay, and root of 144 is just 12 square. 144 is 12 square, so it is just 12. So this can be written as 12 root. Okay, you can take another example, that if you have to write, let us say, cube root of, sorry, so square root of 243. Okay, square root of 243. So you do the prime factors of 243, or you write this 243 as, I know it is 81 into 3. And using the property that root a into root b is root of ab, so this is root of ab, I can write this as root of 81 and root of 3. So root of 81 is just 9, so it is 9 into root 3. Now if you go reverse, in the reverse direction, if you repeat the process in reverse, so if you have to move this 9 inside the square root, you have to square this 9. Right? Once you know this phenomena, the reverse process becomes clear to you. Right? So 288 is 144 into 2. So that 144, which is 12 square, so only 12 will come out. If that 12 has to go inside, that becomes 12 square, which is 144. Okay, I hope it's clear. Moving on to the next example, not example, the next topic, which is rationalizing the denominator. Now, what is rationalizing the denominator? As the word says, we need to make some logic of the denominator. It is not making the sense. So what is not making the sense, and why we are using the process of making it sensible? That is the meaning of rationalizing the denominator. So what is exactly in the denominator that is not, does not seems to be a sensible number? Okay, of course we are dealing with surds. So if any number written in surd form and it is in the denominator, this is not acceptable. Acceptable in the sense that it does not have any physical meaning. Okay, what I mean to say any physical meaning is this. Suppose we have a triangle, a unit length right angle triangle like this. Okay, this is 90 degree, and this length is unit, this length is also 1 unit. Both the perpendicular lines are of 1 unit. So if I ask you what is the length of the hypotenuse, so you will apply the Pythagoras theorem. This will give me 1 square plus 1 square and then square root. So this is root 2. So length of the hypotenuse is just root 2. Okay. Now this triangle is real in the sense that you can make these type of triangles, that you can take the perpendicular lines as of 1 unit length, let us say 1 meter or 1 feet or any unit, right? So this horizontal and this vertical line can be taken as of 1, let us say 1 meter and 1 meter. So hypotenuse will be of root 2 meters, and this length exists in nature, and easily you can represent this on a number line. What is the process of representing them on the number line is this. Let's suppose this is our number line, and I am using the center value as 0, and this length I am taking as 1 unit. Okay, whatever is this length, I am taking this as 1 unit. So after this length I will write the length 1 or the number 1. Then after this I will write 2, and so on. Right, now what I do is I pick up my compass. This is my compass, and I measure its length. Whose length? This root 2 length, which is the hypotenuse. Okay, this much I am getting. right? And I bring this protractor, not compass, rounder at this 0 position, and then I can draw one arc like this. Meaning is whatever is the length of the hypotenuse that can be measured. And if I take the number line as my ruler on the horizontal line, and this represents the 1 unit, this represents 2 units, so this length, the point of intersection of this arc on the number line, these are real lengths, means these are in meters, they exist in nature. So this will come out to be approximately 1.414 something. And as these are irrational numbers, you cannot find out the exact value because we are dealing with lengths. Okay, and this comes in the part of statistics. We are not dealing with that right now, but since it is an irrational number, so this value is not accurate, but approximately till 3 dp it is 1.414. So the point is, this root 2 exists in nature. If I write just root 2, it exists in nature. But when I write 1 by root 2, it does not make any sense. Why? I give you an analogy that you take any integer, let us take 2. This again can be thought of as a length of 2 meters, and if it is written in the denominator, that becomes a fraction, and fractions also exist in nature. Suppose there is a unit length, and if I take half of that length, you get 0.5 unit of length, which exists in nature. Existence of nature meaning is that you can measure that length. But if it is 1 by root 2, I'm not doing half of root 2. Okay? So it is not making any sense. So hence we have that when any surd is written in the denominator form and it is not an integer, it does not have any physical significance. Hence, we need to make some logical conclusion of this number. And hence the topic is rationalizing the denominator. And how we can rationalize is that if there is a fraction, of course this is a fraction, this is a real number 1 by root 2, and you can find out the value 1 divided by approximately 1.414, you will get whatever is the answer. So what I can do is that I can multiply the same fraction by some number. In this case, it is whatever is on the denominator, we will multiply the numerator and denominator with the same number. The benefit of this will be that this becomes root 2 and denominator will become an integer value. So root 2 into root 2 is just 2. So this has some physical significance. Although this is equivalent to 1 by root 2, I haven't changed the value of the fraction. Fraction will remain same. Just by multiplying the fraction, just by multiplying the numerator or denominator by the same value, it does not change its value, but it changes the form of the fraction, which is more meaningful. So 1 by root 2 does not make any sense physically. Root 2 over 2 makes sense. How it makes sense? Because I have told you that root 2 exists in nature, and if I am dividing this by 2, meaning I am bisecting this length. Now it makes sense. Now it is rationalized. That's why the topic is rationalizing the denominator. I hope it's clear now. And what is the method? Method is whatever is, if there is a single root, it is not for each and every case. There are different methods to rationalize the denominator, but the basic is that if there is a single root in the denominator, you just multiply and divide by the same root, and it becomes root a divided by just a. Okay, so let us take some examples or the varieties of questions in which we need to rationalize. Now I said rationalize the denominator of the following fractions. First one is very easy. It is 1 by root 5. So you just multiply this by root 5 and divide by root 5. You get root 5 upon 5. And this is the answer. Okay. Multiply and divide by root 5. Root 5 into root 5 becomes 5 in the denominator. Numerator becomes root 5. So it is rationalized. B part is the new one. Let us understand how we will rationalize this. In these type of questions, when there is a plus root b or a minus root b, whatever the surd is, or you can have two types of surds also. Here you can have root 2 plus root 5 or root 2 minus root 5. Both the numbers can be surds. Okay. What is the method? That you multiply by the number just by changing. You just write here 1 and root 5. You just need to change the sign of the second term. Always the second term. It is not about changing sign of the surd. It is changing the sign of this middle sign. Just change the sign. This from, if it is plus, make it minus, and if it is minus, make it plus. So you multiply and divide by this number, which is 1 minus root 5. Had it been 1 minus root 5 initially, then you will multiply by 1 plus root 5 and divide by 1 plus root 5. What is the reason? The reason is that the numerator will be, you multiply 1 by this, it will be as it is 1 minus root 5. But the denominator uses a very beautiful property of algebra, which is not property, identity of algebra, that it is of the type a plus b and a minus b. Just pause this video and think what this identity will give you. It gives you a square minus b square. Okay, a square minus b square. So a plus b into a minus b. So here a is 1, b is root 5. So I will just write a square, which is 1, and minus b square, root 5 square is just 5. 1 minus 5 is minus 4. So it is minus of 1 minus root 5 over 4. You can take minus inside. You can also write this as root 5 minus 1 over 4. In both these questions, just notice here that this square root can only be removed if we square this. Simple mathematics says this, that square can only be removed, square root, if we square this. This is of course easy, that we multiply root 5 and root 5 so that root 5 becomes a square. That's why it can be written as 5. But here we cannot square this 1 plus root 5 and 1 plus root 5. Okay, you might be thinking that why don't we multiply by the square of 1 plus 5, 1 plus root 5, like this. Here also denominator will become square. Yes, it will become square, but root will be there, because here it is not just a square plus b square, rather it is a square plus b square plus 2ab, because this is 1 plus root 5 whole square. Okay, so if you open this denominator, you will get 1 square plus b square, but there will be root 5. So denominator, in the denominator you will have plus 2 root 5. You have a surd then also if you square this. So we need to arrive at different surd of the form a minus b, so that these two individual values will get squared, and that can only be done if we multiply, if we change the sign of the denominator and then multiply and divide, so that these individual numbers will be squared like a square minus b square. I hope it is clear. Okay, let us take one more example of this. If there is, let us say 3 over root 2 plus root 3, for example. Okay, so if we have to rationalize this, so what I will do, we will multiply the numerator by root 2 minus root 3. I need to change the sign of the denominator. Root 2 plus root 3. Remember, do not skip these values. We are just multiplying and dividing by some number. Okay, this number we are multiplying and dividing. It is not just multiplication and it is not just division. Multiplication and division have to be done both simultaneously. Then only fraction will remain same. So here numerator will be 3 root 2 minus 3 root 3. There is nothing we can do with the numerator. We will just multiply whatever is in the third form, but denominator will again be of the type a plus b and a minus b, which is a square minus b square. So it is root 2 square minus root 3 square. So this is 3 root 2 minus 3 root 3 over root 2 square is 2. This is minus 3, it is just minus 1. So I can readjust the numerator terms like this. This is your final answer. Taking this minus sign inside the numerator, it becomes plus and minus and so on. You can leave the answer by taking minus sign outside also. Nothing wrong in it. Okay, that's how you rationalize the denominator. Let us take one more question of surd. It says that express this in the form of p plus q root 2, where p and q are both integers. Right, again this is an example of rationalization because root 2 is in the denominator. So what we can do here is same repeat process, root 18 plus 10 over root 2, multiply this by root 2 and divide by root 2. Here you will get root 18 multiplied by root 2 plus root 2 into 10 upon, we just have 2. So here we have, I can use the property number 1, root a into root b is root ab. So 18 into 2 is 36. So root 36 plus 10 root 2, 2 in the denominator. Root 36, very simple, it is just 6. So 6 plus 10 root 2 divided by 2. Now I can separate the denominator. Okay, so this can be written as 6 by 2 plus 10 root 2 by 2. And last step is 3 plus 5 root 2. Now if we compare this with the form that is asked, it is in the form of p plus q root 2. So here the value of p is 3 and q is 5. This is your answer. Okay, so I think that's enough as far as surds is concerned and rationalization of denominator is concerned. Rationalization is, again I am repeating, very important topic. Okay, so do not leave this topic for your exam. It seems to be very simple, but it is not. Question can make you do something more also. All right, so thank you so much. We will meet soon.